vitamin D, when there's enough around in the body, it binds to something called a vitamin D receptor, and it fits just right. And when they're bound together, it can unlock a lot of things in the body. If a mother is deficient in vitamin D, this may have severe consequences in the developing fetal brain of her child, because maybe that gene that needs vitamin D to get activated is not getting activated. And as a consequence, there's not enough serotonin being made in that infant's brain. And so it possibly could affect the way that brain develops.
Autism, an increasing epidemic, 200 times increase from when I first started practicing. Are there simple preventive approaches other than vaccines? Hi, this is Dr. Mercola, helping you take control of your health. And today I am joined by a delightful biological scientist, Dr. Rhonda Patrick, who is just a pleasure to interact with. And she's published 2 papers that really expand on some very exciting, simple but powerful lifestyle interventions that could have profound influence not only on autism, but a variety of other developmental disorders in childhood. So welcome today, and thank you for joining us, Dr. Patrick.
Thank you for having me, Dr. Mercola.
So just fascinating work you've done, and we've heard it basically impacting simple things like vitamin D and nutrients in the diet. And we've heard about the influence of vitamin D and autism before, but only from a superficial level. But what you've done in your studies, you've really dug deep and have come up with just a brilliant hypothesis that it seems to have quite a significant validity to it. So I'm wondering if you could pave the way for us and help explain what you found.
Absolutely. So I think I usually, before I get into how vitamin D may be playing a role in autism, I like to kind of explain just briefly what vitamin D is.
Sure.
It's kind of important to understanding how it may play a role in brain function or brain dysfunction. And despite the name, vitamin D is actually, it actually gets converted into a steroid hormone. Mm-hmm. So, estrogen's a steroid hormone, testosterone's a steroid hormone. And vitamin D gets converted into a steroid hormone. And it actually regulates over 1,000 different physiological processes inside the body, which is a lot. It's actually controlling around 5% of the human genome. You mentioned that autism had been increasing about 200-fold.
It was 1 in 10,000 when I was in medical school. And now it's about, the studies vary, but the minimum is 1 in 60, and I've seen estimates even from the CDC as low as 1 in 30. And the projections, here's what's even more frightening. The projections from reputable experts are suggesting that within 10, 20 years, it's going to be half if the trend continues. 1 in 2 kids will have some type of autistic disorder. It's
been increasing by like 500% since the 1970s. And, yes, there is a very strong component of increased awareness, so more people are becoming aware of it, and so diagnoses are increasing, but that just can't account for the exponential increase in autism incidence. And I'm coming from this vitamin D angle, so at the same time that autism incidence is going up, vitamin D deficiency has been going up, or you can look at it the other way, vitamin D sufficiency has been going down. Mm-hmm. So there's the correlation between autism incidence rising and vitamin D deficiency rising, largely as a consequence of people wearing sunscreen. UVB radiation is very important to make vitamin D in the skin, and also staying indoors more, their computer screens, televisions. So there's many different factors that are playing a role in that. But as I mentioned, vitamin D has been shown to control at least 5% of the human genome, and it may even be much more than that. What I found, and what my research identified when I was at Children's Hospital Oakland Research Institute with Dr. Bruce Ames, is that one of those genes that vitamin D is regulating is a gene that encodes for an enzyme called tryptophan hydroxylase, which is responsible for converting tryptophan, which you get from the protein that you eat, into serotonin. And most people associate serotonin with being a neurotransmitter in the brain that regulates your mood. It's important for feeling good. But actually, it does so much more in the brain during brain development and also throughout the rest of the body. So what was really interesting about my research and what I had identified is that first, there are two different tryptophan hydroxylase genes in the body. We have one in the brain and we have one in the gut. The one in the brain makes serotonin in the brain, and the one in the gut converts tryptophan into serotonin in the gut, and they're completely opposite. The serotonin in the gut does not cross over the blood-brain barrier and get into the brain. So
I'm sorry, let me apologize for stopping you, but that is such an important point. And it's a point I didn't really understand. I think most people watching this don't understand, because the reason this comes up is because it's typically taught that, the majority, 80% or more of the serotonin your body is produced in your gut. So then you're thinking it's going to improve brain function, but it doesn't, because it doesn't cross the blood-brain barrier. It's such a central point. So I just want to emphasize that.
Oh, totally. Actually, like 90% of the serotonin made in the body is in the gut. Yeah, and it doesn't cross the blood-brain barrier. It does serve a very important function. The serotonin made in the gut gets taken up by your platelets, and platelets can't make their own serotonin, so they need to get it from the serotonin that's made in the gut. And it plays a very important role in causing platelets to aggregate together, which is important when you injure yourself. If you cut yourself or you bruise yourself, you want to have that coagulation. You want to have those platelets aggregate together to form a clot so that you don't bleed out, have a hemorrhage and bleed out. So serotonin plays an important role in making sure that platelets do that. So you need to make serotonin in your gut. But on the other hand, it's a double-edged sword, because too much serotonin in the gut actually causes gut inflammation. And the reason it does that is because it also activates immune cells in your gut called T cells and causes them to proliferate, and they can start firing away pro-inflammatory cytokines and things like that. And that's actually been shown in mouse models of colitis or inflammatory bowel disease. So you can genetically engineer mice to get colitis or inflammatory bowel disease, or you can give them environmental cues to cause, gut inflammation. And it's been shown if you stop those mice from producing serotonin in the gut, completely takes away their gut inflammation. It resolves very robustly. So too much inflammation in the gut is not good. And what I found is that the telltale sequence I was talking about that vitamin D recognizes in the gene that is important for making that enzyme that converts tryptophan into serotonin in the gut actually turns it off in the gut. So turns it down. It's like, okay, you don't need to make so much of this serotonin, so it kind of keeps it in check, so it's not like going crazy making too much serotonin. Whereas the tryptophan hydroxylase gene in the brain has a sequence that is completely opposite. It's actually consistent with activation. So vitamin D would then recognize the one in the brain and go, oh, turn on, make more serotonin in the brain. And serotonin in the brain plays a very important role in the way you feel. It plays an important role in impulse control, in long-term planning, long-term behavior, in anxiety, memory. So it plays an important role in a lot of different cognitive functions and behaviors. The other thing that serotonin is doing in the brain during early brain development, fetal brain development, is it actually, so when you have a developing fetus, the brain's developing, it actually acts as what's called a brain morphogen. And what that means is serotonin is required in a developing fetal brain in order to shape the structure and the wiring of the brain. And it does this by telling neurons where to go in the brain and what type of neurons to become. And if you don't have serotonin there doing that, this leads to abnormal brain structure, abnormal brain wiring, and in mouse models, it's been shown to lead to sort of the mouse equivalent of autistic behaviors. So serotonin is playing a very important role in brain development. And what's really interesting is that the developing fetus depends entirely on the mother's levels of vitamin D. So the maternal levels of vitamin D cross over, the placenta, cross over the blood-brain barrier, get into the fetal brain, and are activating all those genes So you can imagine that if a mother is deficient in vitamin D, this may have severe consequences in the developing fetal brain of her child, because maybe that gene that needs vitamin D to get activated is not getting activated. And as a consequence, there's not enough serotonin being made in that infant's brain. And so it possibly could affect the way that brain develops. And this is the sort of connection I made between, as you mentioned, Dr. Mercola, earlier. Vitamin D has been linked to autism by many different researchers, and low serotonin has been linked to autism by many different researchers. But no one sort of put the two together as a mechanism going, oh, look, maybe the low vitamin D leads to the low serotonin in the developing brain. And this may be part of the reason why there's an increase in autism. It may be part of the way that low vitamin D leads to autism. And I think there's a very complex interaction between that and also genes. Gene variations in genes are called gene polymorphisms. Mm-hmm. And really all you need to know about that is people have different, variations of genes that lead to the different functions. And many genes involved in serotonin production and serotonin function also can be disrupted, and those have been shown to lead to autism. So if you have someone that's already susceptible genetically to low serotonin, and on top of that, you have vitamin D deficiency, it's like a double whammy, mm-hmm. So I think that that's something that I'd like people to recognize, that there's this interesting interaction between our genes also and the nutrient input, the way different nutrients are interacting with the way we're making serotonin. So the other way is maternal autoimmunity has been linked to autism. Are you aware of this? Of the maternal.
No, I wasn't.
So mothers of autistic children are 4 times more likely to have autoantibodies against fetal brain proteins in their blood at any time. So, you shouldn't have in your blood antibodies against brain proteins. Mm-hmm. That's not normal. But mothers of autistic children are 4 times more likely to have this. In addition to that, some studies that have been done at UC Davis have shown experimentally, when you cause pregnant monkeys to have like a very strong autoimmune response during pregnancy, this leads to abnormal brain development. So having an autoimmune response is not a good thing for anyone, and it's particularly not a good thing for a pregnant mother. And for people that don't really understand what that means, so an autoimmune response means your immune system is so activated that it starts to recognize its own organs, its own tissue as something foreign, like a bacteria or a virus, when no, it's not foreign, this is your own organ, this is your own tissue. But your immune cells, for a variety of different reasons, can't recognize that, and so they start attacking it and damaging the tissue. And in the case of pregnancy, you have a fetus. There's an embryo that starts growing into this little developing fetus. Well, your body can recognize that as foreign. It's like, whoa, what's this? This isn't supposed to be here. Attack, get rid of it. And that can lead to a very severe autoimmune response. But our bodies are wonderfully designed, and we have a protective mechanism against that happening. So we can make a type of immune cell called T regulatory cells. T regulatory cells are very important because the more of them you have, these tell your body, no, wait a minute, this is my body, this is supposed to be here, quiet down, immune system, don't go crazy. So really, the T regulatory cells are a type of immune cell that play a very important role in keeping your immune system in check, making sure your immune system knows what's really foreign and what's your own self. So T regulatory cells are very important. Well, I mentioned earlier that there's another enzyme that we have in our gut that converts tryptophan into serotonin. And this is separate from the brain one. Well, it turns out females also have the same enzyme in the gut in the placenta. So in the placenta, you can convert tryptophan into serotonin. And you want to do this to some degree. But tryptophan also gets metabolized by another pathway into something called kynurenine, which then forms the regulatory cells, those important immune cells I just mentioned, that are important for keeping your immune system, in check so that it doesn't go crazy. And if you don't let tryptophan form the kynurenine, your T regulatory cells plummet. And this has been shown in animal models, in mice, for example. You take a mouse and you delete that enzyme genetically that produces kynurenine, that allows tryptophan to be converted into kynurenine and then into the T regulatory cells. Pregnant female mice have such a strong autoimmune response that they actually end up aborting the fetus because the immune system just attacks it, and it dies. So you want to make sure that tryptophan, not all of the tryptophan is being converted into serotonin in the placenta. You also want it to be converted through this other pathway into T regulatory cells. Well, it turns out that tryptophan actually binds 3 times tighter to the enzyme tryptophan hydroxylase, which converts tryptophan into serotonin. So, back to the vitamin D. If you don't have enough vitamin D around, if you're vitamin D deficient, you may be making way more of this enzyme that binds tryptophan, and it may act as like a sink, trap, where tryptophan's being sucked into that pathway and producing serotonin in the placenta, and the tryptophan doesn't have a chance to then be converted through that other pathway to form kynurenine and T regulatory cells. And this may have a negative effect, particularly during pregnancy, because you're not making enough T regulatory cells, and therefore you start to have a heightened autoimmune response. So, vitamin D has been connected to autoimmunity through a variety of different mechanisms. I think this is one potential additional mechanism that vitamin D may be regulating autoimmunity, because it may quiet down that other enzyme that binds to the tryptophan so tightly and may be acting as a trap for that tryptophan. It just keeps getting sucked into it like a vacuum. Instead, vitamin D turns that down a little bit, quiets it. So now the tryptophan can be more balanced out. It can go this way into forming serotonin in the gut and in the placenta, and it can be going the other way to form the kynurenine and the T regulatory cells. You mentioned it's almost malpractice for a physician not to optimize someone's vitamin D levels, particularly if they have an autoimmune disease. Well, I think that there's a simple solution for OBGYN practitioners, normal just family practitioners, for any female that wants to get pregnant or is pregnant. I think there's a simple solution, and that is, 1, get your vitamin D levels measured, and 2, supplement, make sure you're getting enough vitamin D, high enough to make sure that you have optimal levels of vitamin D so you're not deficient.
So the key message here is, before you even think about getting pregnant ideally, but certainly if you are, or if you know anyone who is, they've got to get their vitamin D tested. It's just has to be done. There's no way around it.
Prevention, is key, like you mentioned. I think making sure you have that vitamin D is very, very important for making sure that the developing brain is getting enough of it, since it's relying on its mother's levels of vitamin D to activate the serotonin in the brain, developing brain.
Okay. Well, it's been known for a while, as we said at the beginning, that vitamin D is useful to lower the incidence of this, but we didn't know why until you uncovered it. So thank you so much for that really brilliant research and for helping us understand the details, because the devil is in the details. And if you can understand the mechanism, then you can begin to better appreciate and have a finer recommendation and revision of what the strategy is to prevent these diseases. So